Okay, greetings to my pre-calculus students. In section 5.3, what I'm going to do is we're going to start by looking at what we call special triangles. And one thing that you want to be sure that you know is the 45-45 right triangle. And you can see that I've got that pictured here. So it turns out that anytime you have a right triangle with, of course, the 90-degree angle and then the two 45-degree angles, that the sides can always be reduced to 1 square root of 2. Okay, so the idea is, I want to show you a couple of things on this. I'm going to first of all show you how to derive this and where this comes from, because that's a good thing to know how to do. So what you want to do is go ahead and draw yourself a square. Okay, and what I'm going to have you do is label each side of that square as 1. All right, and of course we know that we have right angles in a square. All right, so what we're going to do, what turns out in a square is if you take a diagonal of a square, then you form this triangle. And there's a geometric theorem that says that that angle is going to get cut in half. All right, that's a theorem that we know. So it turns out that that angle would be 45, and that angle would be 45. So that you would end up having your 45-45 right triangle. Okay, well, it's a right triangle, so we could call that C, and then we could find the hypotenuse, and you could call this A, and you could call that B, and just use the Pythagorean theorem. So if we did C squared equals A squared plus B squared, then we would have C squared is 1 squared plus 1 squared. That would just be C squared equals 1 plus 1, or 2. Then you can square root both sides, so you would get C equals square root of 2. So that's where that comes from. The derivation's real simple. It just comes from a rectangle. Now, one thing I wanted to just mention on this is this as well. So if you have a square, what would end up happening on this then, if you change the sides, like if you change this to 2 and 2 instead of 1 and 1, then this would just become 2 times the square root of 2, and so forth. If you tripled this, it would be 3, 3, 3 root 2, and so forth. But the idea is the sides can always be reduced to 1 square root of 2, all right? And yeah, of course, that follows the Pythagorean theorem like I showed. So the idea with this is if you did 1 squared plus 1 squared, that is equal to the square root of 2 squared. That's pretty easy to see in your head. That's just 1 plus 1 is equal to 2. Okay? All right. So what we're going to do is, based on that triangle, we're going to fill out the 6 trig functions at 45 degrees then. Okay? So what I'm going to do is, you want to go back to your definitions. I'm just going to write down the definitions at the side here, and we'll start this way. So the sine is the opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay, so we're going to go ahead and fill those things out. And just pick a 45-degree angle. It doesn't matter which one you pick. So we have that. So in relation to this 45-degree angle, that would be the opposite, that would be the adjacent, and that would be the hypotenuse. Okay, so what you do, the sine of 45 would then be 1 over root 2. Okay, and then we would just rationalize that denominator. So I'll go ahead and do that. So you want to multiply by square root of 2 over square root of 2. That will give me the square root of 2 over 2. Because remember what you're doing there, when you do a square root of something squared, the radical comes off. So the answer to the sine of 45 would be square root of 2 over 2. All right. Now what we do with the cosine is the cosine would be adjacent over hypotenuse. So adjacent's 1, hypotenuse is square root of 2. So you would get the same answer. You could rationalize the denominator. Again, you would get exactly the same answer. Okay. And by the way, we've already learned that these angles are complements of each other. So just a good note is that, remember, we learned that if you have the sine of theta, that's the same thing as the cosine of 90 minus theta. Those were called cofunctions. We learned these cofunction identities in class. So the idea is the sine of 45 is the same as the cosine of 90 minus 45. The idea is 45 and 45 are complementary angles because they add up to 90 degrees. So that shouldn't surprise you that they turned out to be the same. Hopefully anyway. All right, so the tangent of 45 is opposite over adjacent. So that would be 1 over 1. So that would just be equal to 1. Okay. Now from here we just do the reciprocal relations. So remember the cosecant is hypotenuse over opposite. It's the reciprocal of the sine. The secant is hypotenuse over adjacent. It's reciprocal of cosine, and so forth. All right. So what we would do on this is the cosecant would be hypotenuse over opposite. So that would be square root of 2 over 1. So that's just square root of 2. And you would get the same answer for the secant. The secant is hypotenuse over adjacent. So that would be square root of 2 over 1. So that would also be square root of 2. And then finally, the cotangent is adjacent over opposite. So that's 1 over 1. It's the reciprocal of the tangent, so you'd expect that to be 1. Okay? So you want to know these things. Okay? You want to know the exact answer. You don't want to use your calculator to have to do the sine of cosine and tangent of 45 degrees. You want to know that. And the special triangle is one way to do that. Later we're going to learn the unit circle. Okay, so we have one other type of triangle that we'll look at. That'll kind of give you what you need to know for the 45-45. The next one is the 30-60. All right, and the 30-60 right triangle goes like this. You have a 30-degree angle, 60-degree angle. Those, of course, add up to 90 like you would expect. And you have your right angle. So the sides go 1, square root of 3, and 2. A couple of things that are kind of helpful on this is the smallest angle. So the smallest angle will have the smallest side opposite. Okay, and that should make sense to you. This is the biggest angle. And the biggest angle should have the biggest side opposite. And then that's the angle that's kind of in the middle. All right, so it should have the middle side opposite like that. So that's a well-known geometric theorem, is the angles, the sides opposite of bigger angles are bigger. Okay, so let me show you how to derive this. This derivation is pretty simple also. So what we're going to do on this is we need to draw... You need to draw an equilateral triangle. Okay. And what we're going to do with this one is I'm going to go ahead. I think I'll just choose to do this way. There are several ways I can do this, but let's just say this is 1, that's 1, and that's 1. So all of the sides are basically the same on this then. Okay. And so what I'm going to do with this is, what happens is all of the angles are equal. So if you take 180 divided by 3, you get 60 degrees. So we end up getting 3 60-degree angles in an equilateral triangle. And then I'm just calling the sides 1. I can call the sides anything I want to, actually. Okay. All right, so it turns out on this, what you do is if you draw an altitude of that right triangle, then you get a 30-60 triangle. So it turns out there's, again, a geometric theorem. You're just going to take the 60 and divide by 2, and that becomes a 30-degree angle, see? All right? It also turns out that this becomes half of that side, so that becomes 1/2. All right, so that's what you end up having on that. Is you have this. All right, now I'll show you kind of what happens on this problem. Now I'm going to go over here kind of at the side. I'm going to draw an equilateral triangle one more time, just so I can kind of make this a little bit neater and more readable on what I just did. So we ended up kind of having this. Okay, we have a 30-60 right triangle. I just called that 1. I chose that to be 1, and then that is 1/2. From there to there. Okay, so I can actually find this side right here. I'm going to call that A, and I'm going to use the Pythagorean Theorem. Of course, this would be C, and then that would be B. So if I do A squared plus B squared, equals c squared, then I should be able to find that side A pretty easily. Okay, so what I end up getting is a squared. If I take a half times a half, I get a fourth. And then that would be 1. Okay, and then I'm just going to solve. So I'm going to subtract a fourth from both sides. So I get a squared equals 1 minus a fourth. Okay, I'm going to get a common denominator, which is 4. Okay, so I would end up having a squared equals 4 over 4 minus 1/4, or a squared is equal to 3/4. Okay, like that. All right, and write that very good. So let's clear that up a little bit. All right, so we have that. Then, of course, you would do the square root of both sides. So you'd end up getting a equals square root of 3 over square root of 4. So that would be square root of 3 over 2. So in my diagram, I'm going to label that as square root of 3 over 2 then. All right, so essentially what I've got so far is, just by using the Pythagorean Theorem, is I have a half square root of 3 over 2, and I have 1, and then I've got my 30-60 triangle like that. So that's where that comes from. Now, what you can do is in a triangle, you can always multiply all three sides of a triangle by the same thing. So I'm going to multiply all sides by 2 just to get rid of the fraction, and then I would end up having this reduced form. So I would end up having square root of 3 there. Okay, I would cross out the 2's there, so I'd end up having a 1 there, and then I would have a 2 here, and then that would give how those sides go then. All right, so we have 1, square root of 3, and 2. All right, and notice in my derivation, the 1 is opposite the 30, the square root of 3 is opposite the 60, and then the hypotenuse is 2. So that's where that triangle comes from. That's the derivation of that. You just got to use the Pythagorean Theorem and a few basic principles behind geometry in triangles. All right, so that's where it comes from. You want to try to remember that. One thing that I tell students on this is there's a statement that I used to hear a lot when I was a kid. It's as easy as 1, 2, 3. Or there was Michael Jackson and the Jackson 5. They had that song ABC. It's as easy as ABC. It's as easy as 1, 2, 3. ABC, baby, you and me. So this one is as easy as 1, 2, square root of 3. I think of funny things like that sometimes. So this one, 1, 2, square root of 3. That's how easy it is. All right. So what we're going to do on the next page is we're going to just kind of work out the trig functions now. With this 30-60 right triangle then. Okay, does this satisfy the Pythagorean theorem? Yeah, of course it does, because it's a right triangle. So if you did a squared plus b squared equals c squared, then a could be the 1, b could be the square root of 3. Remember, a and b are always interchangeable. It doesn't matter which is which. And then c would be the 2. So you would end up getting 1 plus 3 equals 4. Okay, so it's easy to verify that those sides satisfy the theorem. All right, so what I'm going to do first of all is I'm going to take the triangle, and we're just going to fill out the trig functions on this. So again, I'm going to do the same thing. Let's just, with the sign, if you want to write down your definitions, you can. That's opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. That's your SOHCAHTOA. And then the cosecant is the reciprocal of the sine. Secant is reciprocal of cosine. Cotangent is reciprocal of tangent. So what we're going to do is work just with the 30-degree angle. So if you look at the 30-degree angle, then this would be the side opposite. This would be the side adjacent. And that would be the hypotenuse. Hypotenuse is always the longest side. Opposite just means opposite side of the angle that you're considering. So the way this would go is like this. The sine of 30 would be opposite 1 over hypotenuse. So you would end up getting 1/2 is what the sine of 30 is. Okay. Cosine would be adjacent over hypotenuse. So that would be square root of 3 over 2. Okay, and the tangent would be opposite 1 over adjacent square root of 3. So you want to rationalize that denominator. You'll do this all the time in trig class, so you want to get totally solid just to a point where you can rationalize in your head. So that's square root of 3 over 3. Okay? All right, so we got that, and then we'll just do the reciprocals. So the cosecant is hypotenuse over opposite. 2 over 1 would just give 2. Okay, cosecant, or secant, is going to be hypotenuse over adjacent. So that's 2 over square root of 3. Okay, or you can just do the reciprocal, and then you would rationalize the denominator on this also. Okay, so that would give 2 root 3 over 3. That's the reduced form for that. And then finally, the cotangent is adjacent over opposite, so that would be square root of 3 over 1, or just square root of 3. Okay, so that's how you figure that out. If you know the 30-60 right triangle, then it's easy to get the exact answer to the 6 trig functions of a 30-degree angle. Okay. Okay, next thing I'm going to do is I'm going to start all over again with this. And we're going to work with the 60-degree angle as well here. So let me go ahead and I'm going to zoom out on this just a little bit so I can show you this. Okay, so let's focus on the 60-degree angle now. Then this would be the opposite. That would be the adjacent. And that's still, of course, the hypotenuse. Okay, so we'll go through and fill this out. Okay, so sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. Okay, so if you look at 60 degrees, you would be opposite square root of 3 over hypotenuse 2. So that's square root of 3 over 2. All right, then if we do the cosine of 60, that would be adjacent 1 over 2. So that's 1/2. Okay, the tangent of 60, the tangent would be of 60 would be opposite square root of 3 over adjacent 1. So that is square root of 3. And then the cosecant. Cosecant is the reciprocal of the sine. So that would be 2 over root 3. You would need to rationalize the denominator. Okay, so that would end up giving 2 root 3 over 3 as the answer to that problem. Okay, and then the secant is just the reciprocal of the cosine, so that would be 2 over 1 or 2. And then finally, the cotangent is the reciprocal of the tangent, so that would be 1 over root 3. Rationalize the denominator. So you'd end up getting, your answer would be square root of 3 over 3. Okay? All right, so that would be the values of the 6 trig functions. There's a couple of things I do want you to notice on here. I hope that you kind of, as you're learning some of this, that you make a few connections on this. I want you to notice that the sine, let's see, the sine of 30 was the same as the cosine of 60. You would expect that too. I want you to notice the cosine of 30 was the same as the sine of 60. Again, those are cofunctions, so there's these characteristics you get. Notice that the tangent of 30 turned out to be the same thing as the cotangent of square root of 3 over 3. And then also notice this. Okay. Also notice that the cosecant of 30 turned out to be the same thing as the secant of 60. So you have those cofunction relationships on this, and notice that the cosecant of 60 and the secant of 30 were the same. All right, so that's kind of cool. So that's what we expected to happen from your cofunctions. All right, so that kind of wraps us up on the first part of this. So What we're going to do next here is we're going to do just some basic arithmetic calculations at the bottom of the page here. And I'm going to pause this video just for a second and get my triangles kind of set up so we can refer to these as we go. Okay, so we're going to fill out this and just do the arithmetic. We're going to do this without the calculator. So I'm going to go ahead and just fill out these triangles here. So the 45, 45, you want to remember goes like this. Side opposite 45s are 1, and that's a geometric theorem. The side opposite of equal angles will be equal. So we had that triangle. The 30, 60 was like the one I think of the Jackson 5. It's as easy as 1, 2, 3. All right, so it's 1, 2, square root of 3, like that. Okay. And then we're ready to get this put together. So this will go like this. All right, so what we'll do is the sine of 45. So the sine is opposite over hypotenuse. So that's 1 over square root of 2 is what that is. Okay, then we have minus 6 times the cosine of 45. The cosine is adjacent over hypotenuse. So it's also 1 over square root of 2. Okay, and again, the sine of 45 and cosine of 45 are equal because they're cofunctions. So we're going to work this out. We do this, we'll have 3 over root 2 minus 6 over root 2, like that. Well, that will give, you already have a common denominator, so it's negative 3 over root 2. And then you do want to rationalize the denominator. You want to get used to doing that. So we multiply by root 2 over root 2. So we'll get negative 3 root 2 all over 2. So that would be the exact answer to that problem. Okay, these things are checkable on the calculator. The second part of this lesson, we'll learn how to use our calculator on these as well. Okay, the next one we have the tangent of 30. The tangent is opposite over adjacent. So the tangent of 30 would be 1 over square root of 3. Okay, the cotangent of 45. The cotangent is adjacent over opposite. So that would be 1 over 1. Okay, now you want to build these things as you go, but you could also refer to the answers we already got. So what I'm going to do is rationalize the denominator on this. So I have 1 over square root of 3. I'm going to go ahead and rationalize that. And then we have minus 1. So that's going to give square root of 3 over 3 minus 1. And then I'm just going to get a common denominator. Okay, so I would end up getting square root of 3 over 3 minus 3 over 3. So the answer would be square root of 3 minus 3 over 3. Okay, you can't go any simpler than that. Okay, you can't get rid of that radical ultimately or anything, so that would be the exact answer to that problem. Okay. Okay, so these are just exercises in arithmetic primarily, and working with your special triangles. Okay, let's go to the next page, and we will do kind of the same thing on these then. All right, so let's see. Problem C, this says 4 plus tangent squared of pi over 6. Now, if you see tangent squared of pi over 6, what that really means is it means the tangent of pi over 6 squared. Okay, we write tangent squared. Tangent squared just means a tangent of something. You can think of this as tangent of pi over 6 times tangent of pi over 6. Okay, so what I'm going to do is I'm going to write this like this. I'm going to write this as 4 plus the tangent of pi over 6, the whole thing squared. Okay, well, this is obviously in radians, so if you have pi over 6, remember pi is 180 degrees, so really we're looking at 30 degrees. Okay, so if you look at 30 degrees, if you look at this triangle, the tangent is opposite over adjacent. So the tangent of 30 would be 1 over square root of 3. So we're going to end up having 4 plus 1 over square root of 3 squared. Okay. All right. Well, so what we would get is we'd end up just getting this. We get 4 plus 1/3. Okay, because if you multiply that by itself, 1 times 1 is 1. Square root of 3 times itself is 3. So that's 4 1/3. Okay. And you can write that answer as 4 1/3 if you want to. Okay. The other thing you could do is you could say, okay, this is 4/1 plus 1/3. Get a common denominator of 3. So that would be 12 plus 1, or 13/3. Okay. They're both a different way to write the same answer. Okay. Either a mixed number or improper fraction. Okay. The second one here is, or part D. What this really means is it means 1 minus the cosine of pi over 4 to the second power plus the sine of pi over 4 to the second power. Okay, so again, pi over 4, pi is 180 degrees. 180 over 4 is 45. Okay, so we have that. So we're going to look at the 45-degree angle when we do that then. All right, so remember the cosine is adjacent over hypotenuse. So that would be 1 over square root of 2. And then, of course, we would square that. Well, the sine's the same. Okay, they're cofunctions and 45 degrees is a complementary angle of itself. So the sine is opposite over hypotenuse. So that's 1 over root 2 squared, like that. Okay, so we end up getting 1 minus 1/2 plus 1/2. Okay, so what we end up getting is that cancels, of course. So the answer to that problem is 1. All right. Okay. There's another way to do that problem that we'll kind of learn a little bit later, where you could have just done this in your head and boom, boom, you would know it's 1. All right. Okay, so let's see. This last one here. Okay, we got secant squared 45 minus tangent squared 45. So again, you can write this as secant 45 degrees squared minus tangent of 45 degrees squared. Okay, so if we go to the secant, if you look up the secant of 45, the secant is hypotenuse over adjacent. So secant is square root of 2 over 1. So that's just going to be square root of 2. Tangent of 45 is opposite over adjacent. So opposite over adjacent, 1 over 1 would be 1 to the second, like that. So what you'd end up doing here is that would be square root of 2 squared is 2, minus 1. Answer would also be 1. Okay, so partially what we're doing in the first part of this section is you're learning your special triangles, but you also want to be able to do some arithmetic with this, and that's just a good exercise to practice the arithmetic with radicals and trig expressions and so forth. Okay, so that's the first part of the lesson. Okay, second part, what we're going to start looking at is just how to get your calculator. So you want to get your calculator out as you're going through these problems, and you want to do these problems with me. You want to make sure that you're real comfortable in doing this. Okay, so on your calculator, I want to show you a couple of kind of key things. The first thing is you want to know how to change the mode from radians to degrees. So I want to show you how you do that. And I'll write down the keystrokes on this. So in your calculator, you want to identify your mode button, which is here. So if you press your mode button, typically the way that we have everything set up, kind of the standard on this is to have everything kind of to the left. You'll see the fourth line, you have radians and degrees. So right now I'm in radian. So this would mean I could if I enter an angle, it's in radians. Now, if I want to change it to degrees, I just move over with the cursor key, get it blinking, press enter. Now I'm in degree mode. So you want to be able to interchange and go back and forth on that on your calculator. That's real important. So you want to get your calculator in degree mode for these first 3 problems that we're going to put in our calculator. Okay. Anytime you want to clear the screen, so there's this quit button. So if you go second mode, that takes you to a clear screen. Okay. So we're going to put this in, and you have a sine, cosine, and tangent button. So you put in sine 25.8. You're in degree mode, so the calculator knows that it's working with a degree measure. So you press enter, and then we're going to round all these things to 4 decimals. So this will be 0.4352. Okay. When I was a trig student, calculators had just sort of come out. So before my day, you used to have to go to the back of a trig book and look these up in a table. So our teacher actually was old enough that he went ahead and taught us how to use a table, even though nobody does that anymore. We had to do that with logarithms also, I remember. Okay, back in the day. All right, next one, we'd go cosine. So I go cosine. Now, don't use the subtraction symbol, use the negative key. So we just go cosine negative 180. I think that'll give you negative 1. Eventually we're going to learn how to do some of these things in our head. You know, like the one I just did there. I know what the answer of that one is, and you'll know that one too. Okay, let's do tangent. So tangent of 145.45 degrees. And we'll round that one off. Okay, so that is negative 0.688. Now that 5, round the 5 up to 6 so that you get that down. All right, so that's how you do that, nothing to it. Now the rest of these problems are in Radian mode. Okay, so before you put in D, E, and F, you need to change to that mode, change to the mode. So the way you're going to do this is press your mode button, highlight radians, press enter. Okay, so now we're in Radian mode. Then you can quit to go to a clear screen, and then we'll put the rest of these in. Okay, so just type it in exactly as it is. Sine 3 pi, use your pi key, over 8. We are in the correct mode, so this should give you a good answer. So that's 0.923, and then let's take the 8 up to 9. So we have that. Okay, cosine, we'll do cosine 7.5 pi. This will be kind of a simple answer on this one without decimals. That's 0. That's kind of interesting that it did that. That's 0. Now, what that's saying is 5 times 10 to the negative 13. What that is that's a 5 with 13 decimal points like that. And sometimes it turns out that way. That is 0. So if that ever happens, that's 0. It's kind of surprising that turned out that way, but it's based on whatever computer algorithm the calculator is following. So that one's definitely 0. That happens sometimes and kind of freaks students out. So if you see something like that, put 0 down. Okay, next one, something a little unusual will happen on this one too. So if you put in the tangent of pi over 2, you're going to get an error. Okay, and that won't surprise you once you learn this a little bit better, because there's a lot of places where these things are where some trig functions are undefined. So don't put error. The answer is not error. The answer is undefined. Okay, the tangent of pi over 2, when you start learning that a little bit more in depth, you'll understand why it's undefined. We're not quite there yet. So sometimes that will happen. Okay, so that's how that goes. That's how you put sine, cosine, and tangent in your calculator. Now, the way that I teach students how to do cosecant, secant, and cotangent is to just do it like this. So your calculator doesn't have, the secant, cosecant, and cotangent buttons. It doesn't need any more buttons, and you don't need that anyway, because all they are is reciprocals anyway. So what we're going to do on this, we want to go back to degree mode when we put these in. So we want to go degrees, get your calculator in degree mode, and you can go second mode to get it in a clear screen. So the way you have to do this is you go 1 over cosine of 450 degrees. Okay, these are the reciprocals of each other, and the secant of an angle theta is just 1 over the cosine of theta. Same thing with this one. We know that the cosecant of an angle theta is the same as 1 over the sine of theta. So this one you're going to do 1 divided by sine of negative 315 degrees. Okay, so that's how you put that in. Just go 1, first one, 1 over cosine, 450 degrees. Make sure you're in degree mode when you do that, of course. And, okay, then you'll get an error, okay, and that's going to happen some. Okay, we'll learn about why in a little bit. Okay, let's do the next one. Okay, so the next one is we're going to do 1 divided by sign. Use your negative, don't use your subtraction symbol, use your negative, and then 315. And that will give this, 1.4142. Actually, that's the square root of 2. I mean, we'll learn how to get that square root of 2 a little bit later in the class. Okay, but for now, we're just going to use our calculator and get the decimal. Okay, next page. Okay, I'm going to do a few more of these and just get confident with this. So what we're going to do on this is we know that the cotangent of an angle theta is the reciprocal of the tangent. So it's 1 over tangent. So on this one, I just put 1 divided by tangent of 1280 degrees. And that would be 2.747, and then round the 4 up to a 5 like that. Okay, and that's it. Now the rest of these are in radian mode, okay, and there's not a degree symbol. So the thing is, the only time you're going to be in degree mode is if there's a degree symbol in the problem. Otherwise, it's radians, okay? So this one, what we're going to do is you want to go to your mode button, and you want to go ahead and change this to radian mode, okay, like that. And then the rest of these we're just going to put in the calculator. Okay, so this one we're going to go like this. We're going to go 1 over sine of pi. Okay, so 1 over sine pi. Now I think this will give you an error again. Okay, I know why. You'll eventually know why. So that's an error, so that one's undefined. There's dividing by 0 going on is what's happening. Okay, and then the next one, we're going to go just 1 divided by tangent of 0 radians. Okay, so 1 over tangent 0. That should give you 1. Oh, no, that is divide by. Okay, I was thinking, no, the tangent of 0 is 0. So I was going to show you this then. So if you do the tangent of 0, you get 0. So you are dividing by 0. So that one's also undefined. Okay, and then the last one, we just do 1 divided by cosine of 25 radians. Since it's a secant, and then we'll round that off. So that's about 1.0089 if you round that off. Okay, so that's the second part. Real simple. You want to be totally confident that you can go from radian to degree mode and put in any of the trig function values you need to on your calculator. Okay, third and last part of this section is going to be some right triangle applications. And these are kind of nice problems because you can see the practicality and you can see how surveyors measure stuff. I've had students before who have come to take a trig class because they were in surveying and they needed to know trigonometry. They've learned how to use the surveying instruments, but they have to learn some basic trigonometry to do their measurements. Okay, I think in the modern world it's probably totally automated by now, where the measurements just kind of have, the programs have the trigonometry built into it, so they may not even have to know trigonometry anymore, sadly. Okay, so here's kind of the idea. A couple of things is you find measurements. So if you're looking up at an object, we call that the angle of elevation. Okay, so you kind of call this the line of sight. So the angle between your horizontal line of sight and the object you're looking up at is called an angle of elevation. So that's the angle right there that we would call theta. The angle of depression, again, you would have your horizontal line of sight, and then you would be looking down at something, okay, like this. So you're looking down at that object, so that would be an angle theta. Now, you're not going to use a negative angle on that just because it's clockwise. It's just you're modeling that with a positive angle because you're modeling this in a right triangle, see. All right. So we're going to look at some basic applications. This one says, a meteorologist can find the height of a cloud using an instrument called a ceilometer. And it says in the diameter, a light detector set up 300 feet from the projector measures an angle of elevation of 75. We're going to find the cloud height. Okay, my brother's a meteorologist. I'll have to ask him if he uses a ceilometer. I'm sure the answer is no. Again, I think these things are all so automated anymore, but trigonometry is involved, and I could see how this could work certainly on this. So the idea with this is, okay, you have a light detector and you have a light projector. So I guess you're just projecting light up, and it'll illuminate a little spot on the base of the cloud, and then that detector can measure this angle then. So that makes sense to me, so you could figure out the height of the cloud that way then. I'm sure there's other ways that's done, though. So that would be the idea. So what we have basically is we have a right triangle in here. So these problems that we're going to do always have something to do with a right triangle. So the problem said you set the base up at 300 feet. These things are 300 feet apart from each other. Okay, and then it says the angle of elevation, which would be this angle that you're looking up at, would be 75 degrees. So what you're looking at is you're finding the height of the cloud. All right. So it turns out you can do a simple calculation with trigonometry to do this. So the way you do this is you focus on that angle and you focus on this and this. And you kind of talk out what you have. In relation to 75, this is the side opposite over the side adjacent. Okay, and when you're doing these problems, you only want to use sine, cosine, and tangent. You don't want to use anything else. So if you want to remember your SOHCAHTOA, what you have is the tangent would be the correct trig function to use because it's matching up hypotenuse, opposite, and adjacent. All right. So what we would do is we would just write down the tangent of 75 degrees is equal to the opposite h over the adjacent 300. And that's an equation that we can solve. So all you got to do to solve this equation then is you just multiply both sides of this equation by 300, and then you would go to your calculator, see. Okay. So I'm going to do that. I'm going to multiply both sides by 300 to isolate the h, and then we would have 300 times the tangent of 75 degrees would be equal to h. Okay. Well, we want to use calculator. The meteorologist doesn't say that cloud is 300 tangent 75 degrees feet high. You want to give us something that we all understand. Okay, so let's see. You want to put yourself back in degree mode. All these right triangle problems are going to be done in degree mode, of course. So degree mode, and then you just put it in like this. You just do 300 times. You can leave the times symbol off. The calculator knows what you're doing. A 300 tangent 75, and then we'll round that off. So that would be about 1,119.6 feet. You want to get in the habit of using correct units on these problems. To me, that's pretty important. Okay. A lot of you are future engineers or medical professionals and stuff. Units are incredibly important. Okay. So that's how you would use trigonometry and that measuring device to figure out the height of the base of that cloud. All right. Okay. Next page. Okay. So the next thing we're going to look at here is this one's talking about the Eiffel Tower. So I just found some diagrams on the internet that I liked. So this one says that the Eiffel Tower was the tallest tower when it was built in 1889. So what we're going to do is they've given you this measurement here. They've given you an angle of elevation to this part of the tower. To the top of the tower is 85.361 degrees, and this distance is 80 feet like that. Okay, so a lot of times in these problems, it always boils down pretty much to some right triangles. So right now we have this setup. And what we're doing on this, it says find the distance from the top of the tower to the bottom of the tower where the angle was measured. So we're talking now about that side like that. We're not talking about the height of the tower. We're talking about the distance. So we're trying to find the hypotenuse on that then. Okay. So again, what you want to do is you want to talk out what you have. Focus on your angle. This would be side opposite. This would be side adjacent. And that would be hypotenuse. Okay, so again, it's all about using the correct trig function. So the sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent's opposite over adjacent. So which one are you going to use? Yeah, you're going to use the cosine because you're given adjacent over hypotenuse. Okay, so that means you would write down the cosine of 85.361 degrees is equal to adjacent 80 over x, which we're trying to find. Okay, so that's what you'd want to do. Now, what I'm going to do on this is I'm just going to multiply both sides by x. Okay, and what I end up getting on this is I end up getting x times cosine of 85.361 degrees is equal to 80. All right. And then what we'd need to do is divide both sides by the cosine of this angle. And then we'd be ready to go to our calculator. And these problems a lot of times are easy enough that you can kind of rearrange the equation in your head. So ultimately you would have x is equal to 80 over the cosine of 85.361 degrees. And then we would just finish up by going straight to our calculator then. All right. All right, so let's go ahead and do that. We just do 80 divided by cosine 85.361 degrees. And then we can round that off. I'll just round off to like 1 decimal, so that's 989.2 feet. Okay. All right, so that's how that would go. The units are in feet. Be sure you include your units in your answer. All right, so those are kind of the basics. Those are the most basic type of problems you look at. Sometimes they can get a little bit harder. Sometimes you're going to be given a diagram. Sometimes you won't. A lot of times I try to give you a diagram that will help you to interpret the problem, but not always. So this one right here is saying, I've given you this diagram. So it says we have a ranger's tower is located 40 meters from a tall tree. This would be the tower right there, and it's 45 meters from the tree. And then from the top of the tower, so the ranger's on the top of the tower, measures the angle of elevation to the top of the tree to be 28. Okay. And then the angle of depression, that would be looking down towards the bottom of the tree, would be 36 degrees. Okay, now what we're going to do is find how tall the tree is. Well, this particular problem, you got to break this up into 2 pieces here. What you have to actually do is you would have to say, okay, I can figure out that part of the triangle there. So I could call that like X. And then I've got a second triangle here. So I've got a second right triangle there. And I could find that distance, and I could call that y. So then x plus y would just be the height of the tree. So basically, this is kind of a good way to measure this indirectly. There's all kinds of ways that you can measure stuff, but the surveyors have a device that can pretty accurately measure angles. Okay, so what we're going to do is we're going to do 2 triangles. So the first triangle we're going to involve ourselves with has a 28-degree angle. That side's x. Now this side would be 44 because we're going to assume that, of course, is the same distance. If that's 44, so is that. Okay, so if you talk out what you have in this problem, we want to figure out which trig function do we use. Well, this is opposite over adjacent. And opposite over adjacent is the tangent. So we would have the tangent of 28 degrees is equal to the opposite x over the adjacent 44. Okay, so I need to multiply both sides by 44. Then I can go straight to my calculator. So I have x equals 44 tangent of 28 degrees. And then I can get that on my calculator. All right, I'll just round these to 1 decimal as I go through this then. So 44 tangent 28 degrees gives a distance of 23.4 meters. So that's approximately what that distance is then. Okay, now we're going to move on to the second triangle. So the second triangle is this. Okay, it's got, and let me explain why these angles are equal. So these are what we call alternate interior angles. So if that's 36, that's also the same. The idea, this is something you learn in geometry class. Okay, this angle, like if that angle's 20, so is that. That would be if these two lines are parallel. So that line and that line are parallel. So that those are what we call alternate interior angles. Okay, there's more than one way to figure that out. I mean, you could also figure out this angle, and then this angle plus that angle would be 90. But that's real simple. That's something that's real important to not forget. So just to show you, like if that was 60, that would be 60. If that was 30, that would be 30. It's real logical how all that stuff works out. So anyway, this would be 36 here. That would be 44 there. And really we're trying to find this right here. Okay? Or if you want to, I mean, it might be, now that I'm thinking about it, it may be, it doesn't really matter, but I probably could have looked at it like more like this. Okay, that's a 36-degree angle. That's Y, and then that's 44. Okay, like that. Okay, so it looks like this is the same situation. So again, what you have is focus on your angle of 36, and then that's the two sides you're working with. Again, this looks like you're working with opposite over adjacent. So it would be tangent again. So we would have this time tangent of 36 degrees is equal side opposite Y over adjacent 44. Same idea, we just multiply both sides by 44. Okay, so we get 44 tangent of 36 degrees is equal to Y. Then we just go to the calculator. Okay, so that's going to end up being 44 tangent 36, and that's going to be about, let's just round that up to 32 meters, so we get that then. All right, so here's kind of what we get then. We have that, we got that, now we can put together and find the height of that tree. Okay, so step 3 is the height would just be equal to 23.4 meters plus 32 meters, so that would be, what, 55.4 meters. Okay, so that would be the answer to the problem. Okay, so we had to kind of break that one up into 2 triangles to get that to work out. Okay. All right, so we just got a couple of more things we want to do to wrap this up. Now, problems can sometimes be very straightforward. Sometimes they can be a little bit more complex. I think on the next page I got some that are a little bit more complex. So what I was going to have you do is try to solve this problem. So you can do it now or you can watch, but I'm going to just give you time to kind of process this. So I'm going to pause, and you can do the same, and you can, when you resume, then you can see if you got the right answer. And if you got the right answer, just move on. Okay, so if you want to see if you got what I got, we can look over this a little bit. I ended up getting a final answer of 418.1 feet. So I just looked at this triangle. So this triangle has a 70-degree angle of elevation. I called this piece right here X, and that's not the whole thing. That would just be only that part right there. And then the base is 150. So it boils down to working with this right triangle. So again, I have opposite over adjacent. So I use the tangent of 70 is opposite over adjacent. I multiply both sides by 150. You can do that in your head. So X is 15 tangent 70. So when I did 15 tangent 70, I got 412.1 feet. And then notice what I did is you also got to tack on that 6 feet because you're finding that total distance. So you add those two numbers together. That's how I got my answer. Okay. All right. So I'm going to do this last problem on here. And this is just a diagram. We're going to figure out the value of X. There's Later in the semester, when we're done with trigonometry, you'll learn how to do something called law of sines, which makes this easier. If you're a student in no law of sines, you could certainly go ahead and do this problem that way if you wanted to. But right now, I'm going to bypass that. We're just, because all we're learning how to do is write triangles right now. So we need to kind of think about what we can do to solve a problem like that. Now, there's really two right triangles in this problem. There's this right triangle with the 56-degree angle, and then there's the big right triangle with the 35-degree angle like that. So it looks like one thing that we're probably definitely going to have to do is we probably want to see two things. Okay, this is kind of my thought process. We could probably find that. We have enough information to figure that part of that triangle out. And then we could also probably go through and figure out this whole side that I'll call y. Actually, let's not call that x since that's x. Let's call this, let's do this like this. There's no confusion. Let's call this y, and then let's call that z, or whatever you want to call it. Okay? So the thing about this is, if I did z minus y, then I should get x. So I should get that whole part minus that piece should give you the rest. Okay? So there's really two parts of this problem. So the first thing I'm going to look at is, well, let's find y. So with this one, we have a triangle with a 56-degree angle and a side of 115 and a side of y. Okay, so if you talk this out, if you focus on 56, that's opposite and that's adjacent. So it's the tangent. So you would say tangent of 56 degrees is equal to opposite over adjacent. Okay, you could multiply both sides by y. Now there's more than one way to do this, solving the equation. So I'm just going to, I got a fraction, so I'm going to do it that way. So what I end up getting is y times the tangent of 56 degrees is equal to 115. Okay, then I can divide both sides by the tangent of 56 degrees. Okay, and then I go to my calculator. Okay, so I'm going to do y is 115 divided by tangent of 56 degrees. All right, so let's get that put in. Yep, let's see, 115 by 1056, what do we got there? Okay, so we're around to one decimal, so that's about 77.6 units. Okay, I didn't give any units on that, so that's just in general, that's just the units. Okay, so we have that. All right, so we got y. All right, so that's the first part of the problem is figuring that out. Okay, second part of the problem is we need to find what z is. Okay, so now what we're going to do is look at the big triangle. And the big triangle has a 35-degree angle there, a side z, and 115. Okay, so it's still going to be the tangent. It's the same concept. So we'll say the tangent of 35 degrees equals opposite 115 over z. Okay, like that. All right. Now you can do this kind of the same way. You can start doing rearranging in your head if you want to. So I end up getting z times tangent of 35 is equal to 115. And then in your head, you can divide by tan 35. So ultimately, we just do 115 divided by the tangent of 35, and then we'll get what z is. Then we can put the whole problem together, get the answer. Okay, so 115, divided by tangent 35 is going to be this, so that's about 164.2 units. And we're ready to get, put this all together and get the answer of the problem. Okay. All right, so the final step that you would do, step 3, is what we're looking at is x is just going to be the big part, the 164.2. Whoops. Okay, we just take the 164.2 minus the 77.6, and then that should give us that final distance right there. Okay. Okay, so that's 86.6 units, and that will be your final result on the problem then. All right, so that's it. Okay. All right, so that'll wrap that up. That's this kind of material is usually pretty easy for students to learn. These problems right here can get a little tricky sometime, but the idea is applying the trig functions. All right, good luck.